Hi guys, welcome back to my channel. It's another tutorial video guys. This time we are going to continue our discussion regarding principle of work and energy. So basically guys, this is the second part of our first video. Okay, so in this problem we have the 100 kilogram crate is subjected to the force shown. If it is originally at rest, determine the distance it slides in order to attain a speed of 8 meters per second. And the coefficient of kinetic friction between the crate and the surface is 0.2. Okay, let's go back guys to the concept of principle of work and energy. The initial kinetic energy plus the summation of all the work done by each forces on the system along the displacement, let's say 1 to 2, is equal to the final kinetic energy. Okay guys, so dito, ano ba yung mga given natin? So this is the working equation, this is the working principle of this problem. And let's just put this given. Ano ba yung mga given natin? So yung given natin dito, mass of the crate, that is 100 kilograms. So it says here that the crate is originally at rest, therefore our initial velocity is 0. Okay, so determine the distance. Okay, distance it slides in order to attain a speed of 8 meters per second. So ito yung ating final velocity, which is v sub 2. That is 8 meters per second. And the coefficient of kinetic friction dahil ang object natin ay in motion. So we have here the coefficient of kinetic friction, that is 0.2. And the required here is the distance the crate slides in order to attain 8 meters per second final velocity. Okay, so let's say that is distance, okay, d. So what is the distance d? Okay, so ito yung required natin dito. Now, let's continue this principle by getting all of these parameters. Ano yung kinetic energy at state 1, okay, at the beginning of the movement and at the final position of the movement. Okay, so dito, what are the work? What is the summation of work? Ano yung sinasabi ditong summation of work? Now, let's recall that the only force or the only forces that does work on the system are the forces that are going with the displacement. Ibig sabihin, lahat ng forces na same line of direction of the displacement, yun lang ang gagawa ng work. So dito, as we can see in the figure, yung crate natin will move, okay, by analysis, this will move to the left. Okay, gagalaw siya sa left. Because of these forces here na 500 newtons at angle 45 degrees. Okay, with the horizontal. And itong isa pang force that pushes this crate at an angle of 30 degrees with the horizontal. Okay, basically it will move to the left, or yung movement niya, yung line of direction niya is along the horizontal x-axis. Therefore, the only forces that does work on the system are all on the x-axis. Okay, so lahat ng y-axis na force does not do work on the system. Okay, so alin yung mga horizontal forces na yon? Okay, so 500 newtons, of course, that is its x component niya. So this is the x component. Okay, from the tip of this arrow, okay, going outward, this is its x component. So this is 500 newtons. If this is your angle, since this is a triangle, this side here, since this is your adjacent, this is cosine 45 degrees. Okay, what about this 400 newtons? Okay, this 400 newtons, ito yung x component niya here. Or pwede nating ilipat yan sa baba so that we can easily get the angle, which is given naman 30 degrees, so we can put it here. Ayan, this is the x component of 400 newton. So this is again the adjacent side. So the length of this side here, which is the x component, is 400 newtons cosine 30 degrees. Okay, meron din siyang y component, which is, ilagay natin lahat ng forces. But basically, yung mga forces that does work on the system are only on the horizontal. Okay, so ito yung y component ni 400 newtons, which is 400 newtons. So this is now the opposite. So this is sine. Okay, sine 30 degrees. And here, meron din ditong y component si 500 newtons, which is 500 newtons. So this is now the opposite side, 500 newtons sine 45 degrees. So what are the other forces that are acting on the crate? Of course, we have the weight of the crate. That is W. Say W. The weight. So lagay natin dito small letter. Okay, so that hindi tayo ma-confuse. Kasi yung work natin is the capital letter here. So eto, weight natin, and we have here, of course, what counteracts the weight is the normal force. Okay, of course, the body or the crate here is moving to the left. So, binigyan tayo dito guys ng coefficient of kinetic friction. So, hindi natin pwedeng i-disregard yon. So, dito meron tayong frictional force that is acting opposite the movement. So, opposite siya ng movement noong ating crate. So, this is going to the right. So, this is the frictional force F. Okay? F sub F. So, yung frictional force natin, let's recall, so physics can be expressed in terms of the coefficient of kinetic friction and, of course, the normal force. So, that is the coefficient of kinetic friction times the normal force. So, that's why we need, okay, kailangan pa rin natin yung mga y component in order to get this normal force. Ayun, kasi si frictional force does work on the system since it is in the line of direction of the crate, which is in the x-axis. So, what are the forces that does work on the system? Ito, si 500 newtons cosine 45 since nasa x-axis siya. Ito naman si 400 newtons cosine 30 degrees since nasa x-axis siya. And we have here the frictional force since it is also in the x-axis. But we need the y component to get the normal force. So in order to get the normal force, we can actually sum the forces along the y-axis to 0. Okay, so bakit 0? Wala tayong movement along the y-axis or yung ating, pwede naman natin gamitin yung second law. Yung summation of the forces, let's say along the y, is equal to mass times acceleration. So this is upward positive. So, ano yung mga forces upward? So, we have here 500 newtons. So, that is 500 newtons sine 45 degrees. And we have here the weight, which is downward. So, negative yon. So, minus weight. And we have here upward normal force, that is plus n. And we have here downward 400 newtons sine 30. So, this is minus 400 Newton sine 30 degrees. So, that is equal to mass times, ano yung mass natin? The mass is 100 kilograms, but the acceleration along the y is 0 kasi hindi siya gagalaw sa y-axis. Remember that the movement is only along the x-axis. Okay, so weight natin dito, the weight is, of course, that is mass times acceleration due to gravity. Okay, yung mass natin is 100 kilograms. Then, ang ating G is 9.81 meters per second squared. And yung kilogram meter per second squared is an equivalent unit for Newton. So, that is 1 Newton per. Okay, watch out for your conversion. So, we have here 1 kilogram meter per second squared. Okay, you can get your scientific calculators with you for the computation. Okay, so 100 times. So basically that is just equal to 981. Okay, 981 newtons. So the weight of the crate is 981 newtons. So we can actually substitute that weight here in this equation in order for us to get the normal force, N. Okay, so 500 sine 45. So make sure that your calculator is in degrees mode because the angles here are all expressed in degrees, not in radian. So this is 353.55 newtons minus weight, which is 981 newtons, plus N, the normal force, minus 400 newtons times sine 45. I mean sine 30. So that is 200 newtons and that is equal to 0. Okay, extract lang natin si N. So N is, okay, that is 200 newtons. So maging positive siya if you put that to the right, or mag-add tayo ng 200 newtons both sides. 981 newtons to both sides and subtract it. Subtract natin si 353. So minus 353.55 newtons. So the normal force is, so that is 827.45 newtons. So this is our normal force. Okay, so this is the normal force. We can actually get now the frictional force. So frictional force is given by the coefficient of kinetic friction times the normal force. Okay, from the problem, given tayo ng coefficient of kinetic friction which is 0.2. Okay, so that is 0.2 times 827.45 newtons. So ang ating frictional force is given by, okay, times 0.2 lang natin. So 165, okay, 165.49. Okay, that is in newtons. Okay, since we have now the frictional force, let's go back to the concept of principle of work and energy. Okay, so that is the initial kinetic energy plus the summation of work is equal to the final kinetic energy. So let's go back to the concept of work. So work is force times distance. Okay, so dito, so this is KE1, that is 1/2 mass times V sub 1 squared plus the summation of work from 1 to 2, that is equal to kinetic energy at state 2 or the final position, that is 1/2 m V sub 2 squared. So here, ang V1 natin is 0. So basically, this will cancel out here. 0 na to. So this just becomes summation of work from 1 to 2 is equal to 1/2 mv sub 2 squared. Okay, m is given, v sub 2 is given. Extract natin yung distance dito sa summation of work. So let's go back to the free body diagram. So here, the only forces that does work on the system, of course, are the forces na naka-same direction din sa displacement natin, which is the x-axis. So lahat ng forces sa x-axis does work on the system. So ano yung mga forces na yan? So we have this. Eto, 500 newtons cosine 45 degrees. So alin ba yung negative na work? Alin ba yung positive? So ang movement natin dito, as you can analyze in the figure, is going to the left. Okay, to the left part. Okay, if you're looking at the screen. So if 500 newtons is the same direction as that movement to the left, therefore, yung 500 newtons cosine theta, cosine 45 degrees, does positive work on the system. Okay, because it is same direction as the displacement, which is going to the left. Then of course, si 400 newtons cosine 30, since it is also going to the left, it also does positive work on the system. Kasi pareha sila ng direction, papunta din sila sa left. So, eto si frictional force, consider pa rin natin siya because it is also in the x-axis. So, since this frictional force is actually opposite the direction of the crate, yung frictional force natin does negative work on the system. So, that's how you analyze if the work is positive or if it is negative when using the principle of work and energy equation. Okay, so yung tatlong forces na yon does work. So, lagay natin dito. So, yung summation, okay, so this just become, ayan, summation of work from 1 to 2. So, that is 500 newtons. Okay, that is cosine 45 degrees times distance. So, that is force times distance D, yung hinahanap natin. Okay, positive work yon. So, here, ano pa yung dalawang forces? So, we have here the 400 newtons cosine 30. Positive work. Same direction as the movement. So, that is plus 400 newtons, okay, cosine 30 degrees force times distance D. Okay, times distance D pa rin yan. And we have the frictional force which is negative work. Ang work ng frictional force is negative since it is opposite the direction of the crate. So, papunta siya sa right. So, we have here frictional force that is, ayun, 165.49 newtons. Okay, so 165.49 newtons, and we have here times distance, force times distance, and we have here 1/2 mv squared. So 1/2 mass, which is 100 kilograms, and we have here v sub 2, which is 8 meters per second. So this is squared. So using this equation, we can now extract distance d. Ayun. So eto, pagsamahin lang natin siya. So 500 newtons cosine 45 degrees plus 400 newtons cosine 30 degrees minus 165.49 newtons. Okay, i-ano lang natin, i-factor out natin si D since common naman siya doon. So, D here. So, 1/2 times 100. Okay, ito, compute na natin para hindi na siya makasama doon sa, okay, in terms of newtons na. So, 0.5 times 100, you can use your scientific calculator, times 8, okay, 8 meters per second, and that is squared. Okay, 3,200. So, don't forget the units, guys. So, this is 3,200. And we have here, ano yung unit niya? So, this is kilogram. Eto, na-square siya. So, extract natin yung kilogram meter per second squared. And yung meter naka-square pa siya. So, multiply ka ng m dito. Okay, so etong kilogram meter per second squared. So, that is now kilogram meter squared per second squared. Okay, same unit. But itong kilogram meter per second squared can actually be expressed in terms of newtons. So, ito, newtons lang to. Ayan. And of course, newtons here will cancel out to both side of the equation. Ayan. Newton will cancel here since pareha sila merong newton doon. This will cancel out. This will cancel out. And the unit remaining, okay, the remaining unit is in meters. Okay, satisfy natin yung unit of distance, which is a unit of length. So, this expression here is equivalent to 534, okay, 0.47. So, times D, and we have here 3,200 meters. Okay, divide both sides by this expression. Okay, 534. So, that is D equals, okay, 3,200 meters divided by, we have here 534.47. So, the distance traveled in order to attain a velocity of 8 meter per second is, we have here 3,200 divided by 534.47. Okay, so, three significant figures tayo, guys. We have here 5.99. Okay, approximately 6 meters. Ayan, so we have this final answer for this first problem. Ayan, so that's how you apply, guys, if your forces are at a certain angles. Okay, so that's the principle of work and energy. So we have here our second problem. Okay, this time, guys, medyo unusual yung problem natin because we have here the force in terms of the distance traveled. Okay, so here, gagamit tayo ng integrals because as we recall, from the first part of this video. If you haven't watched that video yet, guys, I provided a link above. So, panoorin nyo yung first video, guys, of this topic so that you can easily understand everything what I'm saying here is connected to that first video. Okay, so here, sa problem natin, for protection, the barrel barrier is placed in front of the bridge pier. So, if the relation between the force and the deflection of the barrier is, so look at this, guys, force is equal to, so F is equal to 90 times 10 cube, okay, times x raised to 1/2 pounds. Okay, it is expressed in terms of pounds. So, that is basically pound force. Okay, so don't be confused, guys. That is in pound force, where x is in feet. So, binigyan tayo ng equation of force in terms of distance. So, meaning, force is a function of distance. So, determine the car's maximum penetration in the barrier. So, the car has a weight of 4,000 pounds and it is traveling with a speed of 75 feet per second just before it hits the barrier. Okay, so dito ang hinahanap natin. So, analyze natin yung problem na, guys. So, the car will actually penetrate the barrier. Okay, so the barrier will actually be compressed at a certain distance. So, babangga siya dito sa barrier. Okay, this car will hit this barrier here. Then, pag na-hit niya yan, of course, magde-deform yung barrier. So, what is that maximum penetration in the barrier? Okay, so dito, ano ba yung mga given natin? So, given here is, first write the given, that is force as a function of distance x. That is 90 times 10 raised to 3. So, basically, that is 90,000. Okay. X raised to 1/2. Okay, this is in pounds. Pound force. Okay, so X is in feet. So, the car has a weight of 4,000 pound. Okay, ang weight ng car is 4,000 pound force. And it's traveling at a speed of 75 feet per second just before it hits the barrier. So, just before. So, meaning this is our initial velocity. 75 feet per second. So, after this car, okay, after this car hit the barrier, so, syempre, dun sa maximum penetration, titigil yung car natin. So, the car will stop at that final position which is in the maximum penetration. So, yung V sub 2 natin is 0. Okay, it will become at rest at that maximum penetration. So, what is that maximum penetration? So, yun yung hinahanap natin dito. Okay, that is actually X. So, what is X max? Ayun. So, dito, ito yung mga given natin. Then, as we recall, work can be expressed in terms of integral. So, that is the integral of force, wherein yung force natin can be a function of x. So, we have here force times distance pa rin yan, guys. So, this is force, but our distance is in terms of derivative. Okay, so this is our distance. So, the next step, guys, is to draw our free body diagram or yung FBD natin because dun natin ibabase yung analysis ng ating equation, whether the work is positive or it is negative. Okay, so drawing lang natin yung free body diagram. So this is the free body diagram, guys, of the system. So here, meron tayong weight of the car which is 4,000 pounds, pound force, and of course the normal force that acts opposite the weight, and of course the reaction of this barrier here. So yung force exerted by that barrier. Okay, so here, we can actually apply now the concept of work and energy. So that is the initial kinetic energy KE1 plus summation of work from 1 to 2 that is equal to KE2. Okay, so here, V1 is given. Okay, 75 feet per second. 75 feet per second. And we have here, etong C. Okay, we have here V sub 2 which is 0. So, after the car hits the barrier, of course, at that maximum penetration, the car will stop. Okay, so we have here So KE1, that is 1 half mv sub 1 squared. And we have here the summation of work. So dito guys, yung forces lang that is acting on the x-axis is the force of the barrier. Okay. The force and deflection of the barrier is, we have here this 90,000 x raised to 1 half. So we can actually express that work done by the barrier. Okay, that is integral of force, which is 90,000 I mean. So x raised to 1 half, and you have here the distance dx. And you have here the limit from 0 to, of course, we have here the x max. Ayun. So let's just insert this work of the barrier here. So it is the only force that is acting on the x. So yun lang yung may work done on the system. So we have here plus the work done by the barrier. Okay. So yung work done by the barrier, since na yung force natin is opposite, so yung movement ng car natin is going to the right. Okay, in this analysis, but the force of the barrier is opposite. Okay, opposite siya nung direction ng car. Therefore, yung work done by the barrier, by the force of the barrier is negative since it is opposite the direction of the movement of the car. So that is negative. So yung integral natin. So integral of, we have here 90,000. Okay, x raised to 1 half, and you have here dx, and that is from 0, initial position, to x max. And we have here equals 0. Because ang ating V2 is 0, therefore KE2 is just equal to 0. And might as well just change lang natin yung mga given dito sa M and V1. So the mass of the car, so from weight, that is mass times G. Okay, acceleration due to gravity. So therefore, we can express mass as weight divided by G. Okay guys, so take a look at your units here because this is English unit. So beware of this unit because sometimes English units is really confusing at first. But along practice guys, practice lang talaga, you can actually master these types of unit. Okay, here, yung weight natin is 4,000 pounds. So pag sinabing weight, automatic guys, dapat lalagyan natin ng force yan dito. So kasi yung pound mass and pound force are different. Pero sa problem, hindi na yan sinasabi guys. Kasi pag sinabi mong weight, given na yan na ang pound natin dito is pound force. Okay, so we have here 4,000 pound force divided by G. Okay, for English units, G is 32.2 feet per second squared. So dito dapat yung kalabasan nating unit is pound mass. Pero wala tayong pound mass dito. So we will use the conversion na 1 pound force, which is, this is really actually a very important conversion. So 32.2 pound mass feet per second squared. Okay, so ika-cancel natin yung pound force using this conversion. So that is 32.2 pound mass feet per second squared per 1 pound force. Okay, so this will cancel out here. Di natin kailangan ng pound force. Dapat ma-extract natin si pound mass. Okay, basically 32.2 will just cancel. So that's the medyo weird sa English units. So ito, so it just happens that yung ating conversion na 32.2, okay, is just equal to yung ating acceleration due to gravity in English units. So if G will vary, so this, okay, etong conversion natin will actually change the value kapag ang ating G is not standard. Okay, so here, so yung mass natin, same, that is just 4,000. Okay, 4,000 pound mass. Okay, so gamitin natin tong equation. So that is 1 half mass, that is 4,000 pound mass. And we have here V sub 1. Okay, V sub 1, given tayo, that is 75 feet per second. Okay, so 75 feet per second. So that is squared. So 1 half mv squared. So we have here minus, that is the integral of, okay, 90,000 x raised to 1 half. And you have your dx, and that is from 0 to x max. This is equal to 0. So here, let's just compute for the equivalent of this 1 half. Okay, we have here 1 half times 4,000 times 75 squared. So this is 11,250,000. That is pound mass. Okay, feet per second squared times feet. So here, hiniwalay natin yung feet since this is feet squared, di ba? So if you square this, so feet squared, here, we just hiniwalay lang natin siya in order for us to convert this to foot-pound force, which is a unit of work. Okay, so dito kasi we have here this conversion, we can use that here. Okay, so we have here minus, lagay lang muna natin. So eto si 90,000, pwede natin siya actually ilagay sa right side. So this becomes, magiging positive siya, so plus, okay, 90,000, pwede natin siyang ilabas kasi constant, integral of, okay, so that is just, so equal na siya doon. So equal, so x raised to 1 half, so dx, we have here 0 to x max. So eto, convert natin to foot-pound force. So this becomes, ano yung conversion natin? So that is 1 pound force per 32.2 pound mass feet per second squared. So dapat lahat ng units natin are consistent. So remember that itong equation natin dito is in pound force. Okay? Etong dx should be in feet. Okay, foot-pound force. So dito wala kang foot-pound force, that's why we need this conversion here. Okay, so this will cancel out. Pound mass feet per second squared will cancel out. Ang unit remaining natin is foot-pound force. Ayun, same thing na dito sa atin. Okay, kasi sa problem natin, sinabi that F is in terms of pound force. So F siya. So pound force yun. And X is in feet. So dapat left and right units are consistent. So that's what to look, guys, when solving problems regarding English units. So we have this 11,250,000, okay, divided by 32.2. Unit niya is, okay, foot pound force. And we have here 90,000 integral of x raised to 1 half dx, and we have here, okay, 0 to x max. Just take note that the unit of this right side is also foot-pound force from our given. So integrate na lang natin etong si x raised to 1 half. So recalling, integral of u raised to n, derivative of u is u raised to n plus 1 all over n plus 1 plus c. So the power formula in integral calculus. So we can actually use that here since ang ating exponent is a constant. Okay, n. Constant n, which is 1 half. So n here is 1 half. So 11,250,000 divided by 32.2, that is 349. Okay, 349,378.882. Okay, foot-pound force. Okay, equals 90,000. Okay, so this is in pound force. So from the problem, yung F natin is in pound force. And we have here this integral. Okay, so integral of x raised to 1 half dx. So using the power formula, so that is, so x raised to 1 half, okay, plus 1 divided by 1 half plus 1. Okay, from this formula. So the limit is from 0 to x max. So we can actually divide 90,000 pound force to both sides. So pound force here will just cancel out. Okay, so that is 349.378.882, okay, feet divided by 90,000. Okay, that is equal to x raised to, that is 1 half plus 1, so 3 halves. So divided by 3 halves, ang limit natin is 0 to x max. Okay, so here we have 349,000. So 349,378.882. Okay, divided by 90,000, that is 3.88. So 8819. So this is 3.882. So here, so multiply tayo ng 3 halves both sides. So para makancel natin siya dito. So this becomes x raised to 3 halves, okay, from 0 to x max. So times 3 halves. So we have here 5.82. Okay, so 5.82. So disregard na lang natin guys yung unit because sa problem sinabi that, okay, here para hindi tayo malito, sa problem it says that x is in feet. So whatever the equivalent of x here, yung unit niya is in feet. Okay? So we have here 5.82 is equal to, so ito, apply lang natin yung limit. So upper limit minus lower limit. So x max, okay, raised to 3 halves. So minus lower limit, so 0 raised to 3 halves. So we have here x max raised to 3 halves and we have here 5.82. Okay, raise natin both sides to 2/3 para makancel natin etong si exponent, thus extracting, okay, ma-extract natin si x max. So x max is equal to, we have here 5.82 raised to 2/3. So that is 3.24. So the unit of x is in feet. Okay, so that is now the final answer for this last problem. That's it guys, that's it for today's video. I hope that you have learned from this video guys. This is about dynamics of rigid bodies, principle of work, and energy. So see you guys on my next videos, and if you're new to this channel, just click the subscribe button and the notification bell so that you'll get notified on my future videos just like this video. I hope that you have learned from this video guys. Stay safe sa lahat. Thank you for checking out my YouTube channel.